In this video, we are going to begin learning about arrays. An array is essentially an ordered list of values. We will refer to an array by its name, and we will index each of the values in the array by its numeric value. Now, just like with strings, the indices start at index 0 and go into size -1. So if this example we're looking at, the array is called scores, and scores has 10 integers, and those integers are indexed from index 0 all the way through index 9. Now, whenever we refer to this array value, we are going to refer to it by using the array name followed by the index in brackets, these square brackets here. So for example, if I were to say in code scores 2, what's going to happen is that scores is a pointer which points to where this array is stored. And scores 2 is going to go to the entry that has the index of 2 and retrieve its value. So when the code runs, scores 2 would be replaced by its value of 94. Now, we can do lots of things with this array notation. For example, if I look at this next line of code here, I remember we always assign from right to left, and I'm going to replace the entry in spot 1 with 10. So that would change this value to now be equal to 10. So here we see a variety of other lines of code we can use with our arrays. So in this first example, I am assigning the value 89 into slot 2, which is actually the third position. In this second line of code, I am finding a specific value, adding 2 to it, and then storing the result back into that same value. So notice that we can index an array entry using an actual explicitly labeled integer. We can also use a variable. In the third example, I am accessing these two numbers and then finding their average between them. And if we wanted to find an actual average, since these are both ints and 2 is an int, I would want to adjust this to say divided by 2.0, so that way I could get my answer and save it as a double. And then last but not least, if I want to print an array value, I can simply refer to it in a print statement, just like how I referred to any variable before. You just have to make sure that you use the index to tell the computer which entry you want to print or access. Now, some other details related to arrays. So first of all, an array is going to hold multiple values of the same type. We call the values that it holds the elements. And these elements can either be primitives like ints, characters, or they can be objects like a string, a book, or any other object that we've dealt with. And an important fact to realize in Java is that the array itself is an object. So that name is a reference variable to where the computer can find that array of those variables. Now, when we declare an array, there are a couple different ways that we can do this. The most common way that we see declaring an array is like this line of code here. So first what we are doing is we are saying, okay, I'm going to make an array, and this is the data type that will be contained in my array. So we have to specify what data will be in the array. Then we have to give it a name, and this name is our reference variable name. Just like how we created reference variables for other objects, we have to create a reference variable for the name of the array. Now, I must call the new. I must use the new keyword, and then this right here is kind of like the constructor. Even though it's not officially a constructor, it works like a constructor. This call right here is going to create or construct an array of size 10 int values. And then once it has set aside memory for 10 int values, scores will point to that memory. If we did not have this code after the equal sign, all that would do for us is create a pointer that is currently pointing to nothing, which we call a null pointer. So if we were to break this down, we would go ahead and we would say, all right, let's say I wanted to create an array to hold 50 prices. Okay, so prices are of type double, so I would say double array, meaning that I'm going to hold an array of double values. I'm going to call it prices, and then I will say equals because I'm creating a new object. I will say new, and then this array is going to have 50 slots. So I would say new double, and then I would tell it I wanted to create an array of 50 elements. Now, when we are working with arrays, there's a couple things that we need to remember. First of all, the size of the array is not flexible. If we need to increase the array size, then we actually need to make another array with a larger size and copy all the values over. And it is not flexible, and it must be specified when the array is created. So you can't just say, oh, hey, I'm going to have an array of, I don't know how many elements. You have to know. So if you're not sure how many to put in there, make it bigger than needed because that's easier than running out of space. So here are 3 separate examples. This first one is similar to what I just showed you. If we look at this second example, this basically shows you that we can take this code and we can put it in 2 steps. And this 2-step process is similar to what we will see in our object code that we write. What do I mean by that? Well, let's say this was going to be an instance variable. If this were an instance variable, I would make it private. And then we know that when we're dealing with our instance variables, we declare them before the code and we initialize them in the constructor. So then this would happen in the constructor. So I would first create my variable, and then later I would actually initialize it, construct my object with the proper size needed, and so forth. And then this is just another example of creating another array of a different data type. Just like with strings, a common error is going out of bounds. So when our array is created, like I mentioned, it has a fixed size, and this fixed size or position or index, if we're trying to access the index of an array, then it is going to have an index value between 0 and n-1, where n is that fixed size or that length of the array. If we tried to access an entry that had a negative index value or an index value greater than size -1, we would get an index out of bounds exception. And this is essentially telling us that we tried to access a value that either did not exist or could not exist. And this is automatic bounds checking, which is a nice thing that Java does for us. Now, when we're working with our arrays, we will often be writing loops. That's a very, very common thing that we'll see. And so when we are writing these loops to avoid the off by 1 error, be very careful when you are dealing with the size of the array, specifically with this less than or equals to operator. If we simply just did the less than operator, this line of code would work. Otherwise, what's going to happen is that when it gets to the very last value, we will throw an exception here because we can only hold values from index 0 through index 99. And this line of code should be indented over. I don't know why it's not. Okay, so one of the ways that we can access the length of the array is by accessing the public constant that is called length that stores the size of the array. So I could say scores.length, and that will tell me how many entries are in the array scores. Now, very, very important to remember that this is not a method. And because it is not a method, we do not use those parentheses. This is actually an instance variable that is final because it is a constant, and it is established when the array is created. So it's also important to remember that length holds the number of elements, not the largest index, just like with strings. So if my length is 10, then that means that the largest index is 9. And this for loop is something that we will see a ton of times. And essentially, when you write your for loop, if we're trying to go through every single entry in the array, we want to start at 0, which is the first spot, and then go until the counter is less than the array name dot length. And what this will do is this will essentially visit every single entry in your array without going over. 2 more topics for us. The next one is an initializer list. And this initializer list allows us to instantiate and initialize an array in one step. Remember, instantiate is the word that we use to create a new object. So this is essentially setting aside array space, means that we called the new operator. And then initialize an array means that we give the entries their values. So if I look at this next example here, you will notice that I have created an array for 10 integers and I have assigned all of the values. I did not call that new operator. And the reason why I don't need to call the new operator is because I use this initializer list. It's kind of like a shortcut. Here is another example. I'm adding or creating an array of 5 character codes. An initializer list is nice to use when you know all of the values right at the beginning. If we did not use the initializer list, the alternative is rather tedious. I would have to say units 0 equals 147. Units 1 equals 323, and so on. And if we know all of those values to begin with, that's a rather tedious process to do. It's important to note that when we use an initializer list, the new operator is not used and no size is specified. The size is determined by the number of items in that list. Now, it can only be used in the array declaration. What do I mean by that? If I tried to do these 2 lines of code back to back, this would not be allowed. The only way that this is allowed is if the initializer list is on the same line as when we declare the array reference. If I don't set it up that way, then I can't do it in one step. So that is one limitation of our initializer list. And last but not least, we can pass our array as a parameter to a method. And any changes that are made to the array element within the method will change the original array. And the reason why this happens is because arrays are objects. So when we pass the array name, we are passing by reference. So let's say I had this method here called changeArray that accepted an array of integer objects. And in this code, I go from the first entry all the way to the last entry, and I add 5 each time. So if I were to start out in my main method, and let's say I had an int array called nums, and let's say this array had, we'll just say 4 values, and let's say the values were 11, 13, 14, and 16. So, and then let's say in my main method, I wrote the line of code change array, and I passed to it nums. Well, what's going to happen is inside the method, my formal parameter called array is going to create its own reference variable pointing to the exact same array that nums pointed to. And then it is going to add 5 to each of the entries in the array called array. Well, array points here, so it's going to turn this to 16, and this to 18, and 19, and 21. And then when I leave the method, this array variable disappears. However, nums still refers to the array whose values are now 16, 18, 19, and 21. So nums and array pointed to the same address location. So any changes made by array affected the same array that nums does, because they are in fact pointing to the same spot. And that is because of the pass by reference. All right, that is it for today. Thank you.